Yo, what's up, guys? All right, did not feel like recording a video today, but trying to push myself and yeah, I highly recommend you guys do the same, okay? There are just some days, some crappy days or whatnot, just where you're feeling really tired, but just persevere, okay? And keep on going. Okay, all right, so yeah, this video, I didn't really think this through too well, but um what's mainly going to be about is solving an equation, right? Solving for a variable with fractional coefficients, okay? In this specific example, this is linear, right? This is a line, right? Right, but some of these concepts can be applied to like more general functions, okay? So for my younger kids or algebra 1 kids and stuff like that, don't worry if you don't understand like everything that I'm saying, but just know that it'll come in handy later on. Okay. Okay, so in this example here, we're going to solve for x. And there are a few ways of doing this. Let me show you the fastest way first. Okay. So very similar to the stuff that we did in class, right? You're trying to get this x alone. Okay, so you have to get this -9 out of the way in this 3/5 times. Okay, so here you're gonna add 9 to both sides. You get 21 is equal to 3/5 x, right? And to get x by itself, the fast way, right, is just multiplying the both sides of the equation, or you could say the equation, by the reciprocal of 3/5, which is 5/3. Okay. So this is a lazy way of writing it. You could also do it like this. Like if I were to, let me rewrite that equation like this. Okay, and if you want to show that you're multiplying both sides by 5/3, you can just put 5/3 like that on the left side. You could also do it on the right, by the way, but yeah, okay. But I'm gonna write it like this because this is how I learned it. Is more convenient, I think. Okay, so here now you can use like this bootleg distributive property, and this literally means just distribute to both sides. So so 5/3 times 3/5, what's gonna happen to that is that's gonna cancel out and turn to 1. So that goes away, and it's gonna be 1x, and 1x is the same as saying x. And then the other side is going to be this thing, right? So 5/3 times 21, this problem. And what that's going to be is 35. Okay. There are fast ways of simplifying this. You know, one way is just going across like that. Another way is if you learn how to simplify where how many of this denominator goes into that. But yeah, we can review that at a different time. If you have questions, just let me know. Cool. So yeah, so one way of doing it, x equals 35. Okay. All right. So now let me show you another way of doing this problem, but this one's going to be more annoying, and you don't want to take this path actually. Okay, but I just want to show you like you could still learn something from it, right? So here, let me rewrite the problem. So solve 3/5 x minus 9 is equal to 12. Okay. And notice that here I added 9 to both sides first, but I know in class some students wanted to get rid of this. Okay, you could get rid of this first. Okay, and the way that you get rid of this is by multiplying the entire equation by same thing, the reciprocal. So once again, my bootleg form for distributing, right? You do this, right? And again, you're multiplying 5/3 with the thing on the left side of this equation and the thing on the right side. Okay, so but here on the left side there are two terms, right? This thing and this. So that means that when you multiply by 5/3, you have to actually multiply to every single term. So you have to do that on the left side, and then on the right side you do this part. Okay, Cool. So here, yeah, what's going to happen is that this first part, the 5/3 times 3/5 x, well, like what we said here, that cancels out, turns to 1, right? And it's going to be 1x, so it's going to be x. But then you also have to multiply 5/3 with this -9, right? And when you do that, you're going to get -15, okay? So it's like -45/3, or use other tricks, okay? So x minus 15. Right? And then finally, you have to multiply the 5/3 with this 12. And when you do that, you're going to get 20. Okay. Yeah, if you don't understand like how I'm getting these numbers, and just the topic that you should review is operations with fractions, because that's all I'm doing. Okay. And also like simplifying fractions. Okay. So here, yeah, and then you guys know what to do. Next step would be to add 15 on both sides. All right, and then once again, we get x is equal to 35. All right. Right. Once again, in practice, this one's a little bit more tedious, right? Because you're dealing with fraction operations, and it's very likely that you might make a mistake, or more mistakes compared to this one. Okay, cool. I mean, we could also do a third way, where I see a lot of students doing this, right? So let me rewrite the problem once again. So write 3/5 x minus 9 is equal to 12. And to dodge this, right, to dodge operations with fractions, I see a lot of you guys just, changing this fraction into its decimal equivalent. You can do that as well, right? But so here, this 3/5, old topic, that's equivalent to saying 0.6 or 0.6x, okay? 0.6x, and then you just rewrite the other stuff. And here you solve for x, same way, right? So then here you add 9, 21 is equal to 0.6x. And then here I see students, what they'll do, they'll whip out their calculators, and then they would be like, oh yeah, let me divide both sides by 0.6, which is valid. It's valid, okay? And then when you say 0.6 divided by 0.6, that's once again going to turn to 1. So you're going to get x by itself on the left side. And when you put this in the calculator, 21 divided by 0.6, you're also going to get x equals 35. You better get that, actually. If not, then something's wrong, okay? All right, so just 3 different ways of doing it. Once again, this pink one is the best way, in my opinion, or if you're doing this by hand, okay? And then the green and blue one, I mean, the blue one would be okay if you like decimals, but I mentioned in class that not all fractions have nice decimals like this. And by nice, I mean more rigorously, I guess, called like terminating decimals. Okay, so this trick doesn't always work, but for nice fractions, for some fractions you can. Okay, and then this one, in practice, you don't do this, right? But this thing kind of gives you a better feel for what it really means to multiply an equation by a number on both sides. Okay, so the big takeaway here would be that when you do this, you have to do the multiplication to every single term. And once again, the terms are the math expressions that are separated by the plus and minus signs. Okay, so something like this. So 1, 2, 3 here, 6 here, there'll be 4 terms. And inside these squares, you just put like math expressions. Okay. All right, cool. And that's about it. And if you have any questions, feel free to leave them there. And yeah, all right. See you guys. Yeah.